Welcome back class 10. Today we are going to discuss chapter number 6 and that is all about triangles. In this chapter we will discuss the properties of congruency. Basically congruency, the properties you have already seen in class 9th maths book and you have done, you know each and everything about congruency. In this class, we will discuss about similarity. Similarity, that means about similar figures, especially for triangles. Actually, you are familiar with triangles and many of their properties from your earlier classes. You have studied about congruence of triangles in details. Recall that two figures are said to be congruent if they have the same shape and the same size. That means for congruency the figure must have same shape and same size. In this chapter we should study about those figures which have the same shape but not necessarily the same size. Two figures having the same shape are called similar figures. That means if I am asking about similarity or similar figures, that means what do you mean by similar figure? First of all, you should understand about similar figures. What do you mean by similar figures? That means figures which have the same shape having the same shape but not necessarily the same size. The same size are known as similar figures. So when we are talking about similar figures, it means that figures having the same shape but not necessarily the same size are known as similar figures. Okay. In particular, we shall discuss the similarity of triangles and apply this knowledge in giving a simple proof of Pythagoras theorem later. Okay. So now about similarity, first of all you should understand that suppose I am drawing two triangles. Here one triangle and here another triangle. That you can see that triangle ABC and triangle DEF, two triangles are there. You can see there the shape are same. Triangle ABC and DEF, triangle ABC is a small triangle but triangle DEF is a bigger triangle. Their shape are same but their size are not same. If I am telling angle A is equal to angle D and angle B is equal to angle E and this angle C is equal to angle F, that means the corresponding angles are equal here. Corresponding angles, angle A correspond to angle D. Angle A and D, the measure of angle D A is equal to the measure of angle D and the measure of angle B is equal to measure of angle E. Like that, the measure of angle C is equal to measure of angle F. That means both these triangles are similar, and I can use one symbol there, that triangle ABC is similar to triangle DEF. This sign is known as the sign of similarity. Triangle ABC is similar to triangle DEF. Basically, what are the conditions for similarity of two triangles? The corresponding angles should be equal. If in two triangles the corresponding angles are equal, that means these two triangles are similar to each other. Suppose I am drawing two circles. One circle is there, another circle is there. You can see both are the circles. That means two circles are always similar. Two circles are always similar. This circle and this circle. Suppose its radius is a small r and its radius is capital R. There is no relation between the radius, but the triangles are similar. Okay. A very common example you can take. Okay. A kitten is similar to a cat. A kitten is similar to a cat. Okay. Like that, a human baby is similar to a human. Okay. So there is no need to see the size, you need to see the shape only. If the shapes are same, that means the figures are similar to each other. One more thing is very important here, that all congruent figures are similar, but all similar figures are not congruent. So always keep in your mind that all congruent figures are similar, but all similar figures are not congruent. This is very important thing. You should keep this thing in your mind, that congruent figures are similar, but similar figures are not congruent. Suppose you are drawing a small square. Suppose I am drawing a small square and I am drawing a big square. In this two square, these are the square. In a square, all the sides are equal. Here, suppose I am having a square, its name I am writing as ABCD, and here I am having a square, its name is PQRS. Here, as you know, each angle of a square is 90 degree. Each angle of a square is 90 degree. Here, both the squares, suppose all the sides are equal. One square is smaller, another square is bigger, but square ABCD is similar to a square PQRS. Both the squares are similar, but they are not congruent. So we can say all congruent figures are similar, but the similar figures did not be congruent. This is most important fact. One more fact I am talking about, two polygons of the same number of sides are similar. Once again I am repeating, two polygons of the same number of sides are similar if their corresponding angles are equal and their corresponding sides are in the same ratio. Any type of figure you can take, any type of polygon you can take, they may be either you are having a pentagon, hexagon, octagon, nonagon, any type of polygon, they may be similar. How they can be the similar? If their corresponding angles are equal and their corresponding sides are in the same ratio, that means these two figures are similar to each other. Now I am talking about exercise 6.1. Exercise 6.1, we need to exhibit the concept whatever we have studied just now. By taking those simple concepts, you can do exercise 6.1. So just look at the question of exercise 6.1. There is some fill in the blanks type question. Here question number 1. Just take out your book. Always whenever you are starting the class, you must take your NCERT book along with you so that you can see the questions. So here you can see question number 1 of exercise 6.1. Fill in the blanks using the correct word given in brackets. What is there? All circles are dash. All circles are dash. Just I have told that what answer you will be writing in number 1. All circles are, the option is given there, congruent and similar. What you will write? All circles are similar. all circles are similar. So you need to select here similar. All circles are similar. Just we have talked, we have seen that two circles are always similar. Number second, all squares are, again once again you can write, all squares are similar. All squares are similar. All squares are similar. Then number third, all dash triangles are similar. All dash triangles are similar. Which type of triangle may be similar? All isosceles triangle or equilateral triangle. Which triangle? Equilateral triangle. All equilateral triangles are similar. So there you have to select equilateral triangle. You need to select equilateral triangle. Okay. So there you need to write all equilateral triangle are similar. Their triangle word is already written. You need to write only equilateral. So all equilateral triangle are similar. Two polygons of the same number of sides are similar if number A, their corresponding angles are equal. Their corresponding angles are equal. So in 4 number, 2 questions are there. In A number you need to write their corresponding angles are equal. In A number, fill in the blanks, you need to write equal. And in B number you need to write, in B number their corresponding sides are proportional. Their corresponding sides are proportional. Okay. So this is question number 1. What you will write in fill in the blanks type question, that just I have given you. Now you can see question number 2. Give 2 different examples of pair of similar figures. Similar figures means you need to give only just 2 examples. Give 2 different example of pair of similar figures. So number 1, 2. What you will write for question number 2, and in 2, 1 number similar figures. You can write a square and regular hexagon. I am writing for number 1 squares. All squares are similar. You know it. And number B, this is to question number 2, 1 similar figures, squares, and number second, what you can write, number A squares, and number B all you can write equilateral triangles. So number B you can write equilateral triangles. Equilateral triangles. So these 2 figures you can take, or squares, and you can also write your answer regular hexagon. Regular hexagon, that means the hexagon is having 6 sides, and if you are talking about regular hexagon, that means any size. Whether you are making a hexagon by taking the side 2 centimeter, and another hexagon you are taking the side as 3 centimeter, another hexagon you can draw by taking the side 5 centimeter, but it should be regular, that means all side must be equal. Then these 2 hexagon will always similar to each other. So this is the answer of question number 2.1. Now 2.2, example of non-similar figure, 2 triangles of. Now number 2, what answer you will be writing? They are asking the examples of non-similar figures, 2 triangle of different angles. You can write 2 triangles of different angles. 2 triangles of different angles. Different angles. That may be that you can write that 2 triangles of different angle never becomes the similar triangles. Then 2 quadrilateral of different angles. In B number you can also write 2 quadrilaterals of different angles. different angles are not similar. So here you have seen that whatever we have discussed before exercise 6.1, that was only the introduction part of triangles, and from there you can do all the question of exercise 6.1. Whatever we have discussed there, you can apply to do the questions of exercise 6.1. These are very easy and simple questions. Now I am talking about similar triangle. Especially now I am going to talk about similar triangle, that is for exercise 6.2. Okay. So I hope that 6.1 you have understood, and here just we have discussed about similar similar figures only. Just we have discussed about similar figures. So here most important statement, you have seen that all congruent figures are similar, but all similar figures are not congruent. This keep in your mind and go through the introduction part in your textbook. Read it very nicely, try to understand. If you can see there are definition, you can underline it, okay, and you have to learn those. I have discussed already. Now here similar triangle, you can see similar triangles means two triangles are similar if their corresponding angles are equal and their corresponding sides are in the same ratio. So now I am talking about similar triangles, that is similar triangles. Similar triangles. Now similar triangle, just I have discussed that if you are drawing two triangles, suppose I am taking one triangle and another triangle I am taking little bit bigger. In these two triangles, its name is ABC and its name is DEF. Here what I have told you, angle A is equal to angle D and angle B is equal to angle E and angle C is equal to angle F. So these are the corresponding angles. Here in triangle ABC and triangle DEF, what I have told you, angle A is equal to angle D, then angle B is equal to angle E and angle C is equal to angle F. Here one thing must be taken care, that angle A is corresponding angle of angle D. A is corresponding angle of angle D. That means you can just write it that yes, angle A is corresponding to angle A, and the corresponding sign which I have told you here, vertex A is just correspond to vertex D, and here vertex B is just correspond to vertex E, and here vertex C is correspond to vertex F. So this should be taken care that corresponding part should be followed. Corresponding part should be followed, that A, the position of A is there and here is the position of D. So both should be in the same position. Both should be in the same position, then only this is called corresponding parts. You cannot change the corresponding parts. Now these two triangles are similar, two conditions are given there. Their corresponding angles are equal and their corresponding sides are in the same proportion. That means when I will talk about similar triangle, then this thing you have to note down, just you note down for your understanding. Okay. Now here I was talking about that two triangles are said to be similar triangles are said to be similar if number one, the first condition is there that their corresponding angles are equal. Their corresponding angles are equal. This is the first thing, and the second thing is there that their corresponding sides are proportional. Their corresponding sides are proportional. This is the condition for the similarity of two triangles. You have already seen that corresponding angles means angle A should be equal to angle D, angle B should be equal to angle E, and angle C should be equal to angle F. And when I am talking about this corresponding sides, that means AB upon DE. Here it means what? First, just we have discussed already. In second, AB upon DE should be equal to BC upon EF, and it should be equal to AC upon DF. It should be equal to AC upon DF. That means AB upon DE should be equal to BC upon EF, and it should be equal to AC upon DF. This is known as the corresponding sides. That means the corresponding sides are proportional. It means this. That means you need to write the ratio of the side AB and DE, then BC and EF, then AC and DF. This is known as the corresponding sides. Now, here theorem number 6.1 is there. One theorem is there, that is 6.1. If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct point, the other two sides are divided in the same ratio. Just you can see this proof is required. You need to prove this theorem. So let us start the proof of theorem number 6.1 theorem. You can copy down from your textbook. Now we will discuss its proof, how to prove this theorem. So first of all, theorem number 6.1. So here theorem 6.1 I am going to discuss now today. So this theorem is, if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct point, the other two sides are divided in the same ratio. Let us see how I am doing it. Just you can take any, you need to draw any triangle, any shape of triangle you can take, it's your choice. Name it as A, B, C. Now what they have told, that after taking ABC, you have to draw a line parallel to one side. That means I am taking one line which is parallel to BC. Suppose here a line is taken which is just parallel to BC, and it is intersecting these two sides at the points D and E. Suppose this point is D and this point is E, DE, and here the line DE is parallel to BC which is taken. So here we need to write the statement for the proof, that when we will start proof of this theorem, how to write this proof. Let ABCD be a triangle. In this you need to write, let ABC be a triangle, in which a line, in which DE is parallel to BC, in which DE is parallel to BC, okay, in which DE is parallel to BC. This is taken. We need to prove AD by DB. Then to prove, what to prove? What to prove? AD upon DB is equal to AE upon EC. AD upon DB is equal to AE upon EC. So here extension just I have done to show you. No need to extend it. If you don't want to extend, don't extend it. Just I have extended so that you can see that these two lines are parallel to each other. Now what to do? Now we need to do some construction to prove it. So what are the construction? Now first you need to join B to E. First construction what will do? Join BE. B to E we need to join. So join BE, then join DC. Okay, first of all join BE, then join CD. Okay, then draw the perpendiculars. What perpendiculars? Here D2 M and E2N. Two perpendiculars should be drawn. That means I have drawn two perpendiculars DM. Suppose this is DM and this is EN. So DM and DN are the perpendicular drawn on the side. DM is drawn on the side AC and EN is drawn on the side AB. So this time we need to write the construction. For the proof we need to write the construction. What construction? I have done. First of all join B to E, then C to D, and draw DM perpendicular to DM perpendicular to AC and EN perpendicular to AB. This is your construction part which I have done to prove it. So if the construction is done, then you can find the area of triangle ADE. Triangle ADE, first of all area of triangle ADE. Area of triangle ADE, as you know, area of triangle is given by half into base into height. So when I will talk about area of triangle ADE, now we can start to write the proof. Since area triangle ADE, area triangle ADE is given by half into base. Base is AD, and height is EN. That we can write here. Area of triangle ADE can be given by half into base. Base is AD and height is EN. So this is area of triangle ADE. Then area of triangle BDE and area triangle BDE. Area triangle BDE, that will be half into here. This time base is BD, base is BD, and your height is EN itself. Height is EN itself. Okay, because this is the scalene triangle and its height is going outside of this triangle. As triangle EDB is a scalene triangle, you can see the measure of angle EDB is more than 180 degree. So its altitude is going outside. So we can write area of triangle BDE equal to half into BD into EN. Okay. Now in the same way we can find the area of triangle AED. Now you can find the area of triangle ADE and area triangle ADE or AED. Okay. Area of triangle AED, it is better to write AED because ADE I have written already half, and this time I am taking base as AE, base as AE, and height as DM, height as DM. Again area of triangle BED and area triangle BED. Okay, this time CDE, this time area triangle DEC, that also I can write DEC. All are the same triangles, half into base is CE, base is CE, and your height is again DM, height is again DM. So here I have written the area of these 4 triangles first. After writing the area of 4 triangles, now we need to find the ratio. Now you can take now area triangle ADE, area triangle ADE upon area triangle BDE is equal to half into AD into EN, and it is half into BD into EN into EN. This half cancel, this EN and EN cancel. So ultimately you are having area triangle ADE upon area triangle BDE is equal to AD upon BD, AD upon BD. This result you are getting. This is your first relation which you have got. This is your first relation which you have got. This is AD upon BD or DB. Okay. So till here first of all you copy, then I am writing the remaining part of this statement. Now after writing till here, once again I am going to write here statement. You can write and give the and sign, and as there is no space I am writing here, and once again I can take area triangle AED and area triangle AED upon area triangle DEC, that is equal to half into AE into DM into DM and upon half into CE into DM, CE into DM. Once again you can see half cancel and dm cancel. That means it is clear that area triangle AED upon area triangle DEC is going to be equal to AE upon CE. AE upon CE or AC, whatever you want to write, you can write. This is your relation number 2. So as you have seen that your relation first and second appeared. Now area AED and area ADE. AED and ADE both are the same triangle. Both are the same type of triangle. So their area remains same. Okay. And another thing, the DEC, you can see DEC, area triangle DEC and BDE, DEC and BDE. Okay, DEC and BDE, both the triangle are in between. Also we can write also triangle BDE and triangle DEC both are in between the same parallels, in between the same parallels and on the same base, As you know, two triangles drawn on the same base and in between the same parallels are equal in area. This you have studied in class 9. Therefore, you can write area triangle BDE is equal to area triangle DEC. Okay, area triangle BDE is equal to area triangle DEC. So this is your third conclusion which you are writing over there. So in first conclusion and in second conclusion, you have seen that here AED and ADE both are the same triangle. That means their area are equal. And at the denominator, here in the first number you have written area triangle BDE, and in second you have written area triangle DEC. Actually both are having the same area. This conclusion you are writing in statement number 3. So just you can write here from first, second and third what you have observed. After looking at first, second and third, you can say that first and second both are equal. First and second both are equal. Okay, therefore you can write first is equal to second. Third, we observe, you can write here, we observe first is equal to second. That means relation first is equal to second. That means we can write AD upon BD, AD upon BD is equal to AE upon EC, AE upon EC. This is known as the basic proportionality theorem. This is known as the basic proportionality theorem. Okay, that means if a parallel line is drawn parallel to one side of a triangle to intersect the other two sides, that means this line is dividing the other two sides in the same ratio. This result will be used to solve many questions. So at first you should practice this proof and try to understand the theorem. Okay, thank you for today. On coming day I will be showing you exercise 6.2.